The topic is understanding Kubernetes services. In Kubernetes, a service is an abstraction that defines a logic set of pods and a policy by which to access them. Because pods are ephemeral, they can be destroyed and recreated with new IP addresses. Services provide the stable networking required for reliable communication. We must know that pods are ephemeral in nature because it can be destroyed and recreated with new IP addresses. Meaning, even if we have created pods with replicas controller inside the deployment YAML, the new pods that are created after another getting destroyed will have the new IP addresses, which is not same as the before. New pod will not have the same IP address of the destroyed pod. So we need a services concept in Kubernetes that creates a bridge between those volatile IP addresses of destroyed and new pods and gives a stable IP address for accessing and troubleshooting our clusters. Core functions: service discovery. Instead of tracking individual pod IP addresses, services use labels and selectors. The service monitors pods with specific labels and automatically updates its internal list of healthy targets. So services does not rely or depend on volatile IP addresses that are getting destroyed and that are created with new pods. So it depends on labels that we assign while creating a deployment.yaml, which specifies labels with respect to the pods that are created. So what will happen? It does not rely on volatile IP addresses and it will rely on those labels. So it redirects those volatile or new pod IP addresses with respect to the labels, and it gives new or fresh cluster, node or load balancing IP addresses. So now what is load balancing? It is a service that acts as a single entry point, that is a virtual IP address. It receives incoming traffic and distributes it across all pods that match its selector, ensuring no pod is overwhelmed. Load balancing is a single entry point for a virtual IP address, meaning if you decided that your application is stable and it has no or minimal errors and you want to deploy it, so you would be using load balancing concept that would give your application a stable virtual IP address that has the capability of load balancing, meaning with respect to the number of pods inside your cluster, the load or the traffic that is received within the application or the single pod would be divided equally or would be divided with respect to no pods getting overwhelmed in this process. So that single virtual IP address is enough to access the application, but that virtual IP address is not professional, so we use Route 53 or other providers, that is GoDaddy, and put that virtual IP address of load balancing and create a custom and redirect that to the custom domain name service. Now, DNS resolution. In Kubernetes, it provides a DNS service. Any service created is assigned a DNS name. For example, my API service, allowing microservices to communicate using names instead of hard-coded IP addresses. So we know that IP addresses are volatile with respect to pods when it gets created and it gets destroyed. So there must be a concept that is DNS service that provides DNS service name, that is, for example, my API service. It allows microservices to communicate using names instead of hard-coded IP addresses that are volatile in nature. So now workflow. Selection. The service uses a selector to find all pods with matching labels. Endpoints. Kubernetes maintains an endpoints object that holds the real-time IP addresses of those matching pods. Routing. When traffic hits the service IP, the kubeproxy component on the nodes routes that traffic to the one of the pod IPs listed in the endpoints. So accessibility of your application or pods, it's through labels, and those labels are communicated by endpoint object that holds the real-time IP address of those matching pods, meaning those volatile and new real-time IP addresses are maintained by Kubernetes as endpoints. And when the traffic hits the service IP, the kubeproxy component on the nodes route that traffic to one of the pod IPs listed in the endpoints. So endpoints has the real-time IP addresses that are created and it keeps those information real-time, and kubeproxy component of the nodes routes that traffic to one of the pod's IPs in those endpoints. Now, service types and accessibility. Kubernetes offers different levels of exposure depending on whether the traffic is coming from inside or outside the cluster. First is ClusterIP internal. Function, the default service type. It exposes the service on the internal IP within the cluster. Access, only reachable by other resources inside the same Kubernetes cluster. Use case, internal databases, caching layers or private microservices. So Kubernetes offer different levels of exposure depending on the traffic, whether it is coming from inside or outside the cluster. The first was ClusterIP. ClusterIP, its function is for communication between the microservices, that is database, front end, back end. All the services communicate through ClusterIP, meaning inside the Kubernetes cluster. Now NodePort, that is internal or external. Its function, it exposes a service on a static port, typically 30,000 to 30,767 on each worker node's IP. Access reachable from outside the cluster by calling node IP NodePort. Use case, development environments or scenarios where we want to route traffic to nodes manually without cloud managed load balancer. So NodePort is a static port that has range between 30,000 to 30,767 on each worker node. However, it is a volatile IP address, meaning you can still access the application using node IP address, which is still not secure, but you can access it. But that nodes change and that are volatile, so it can change anytime. But that is used in development environments or scenarios where we want to route traffic to nodes manually without cloud managed load balancer. So you can remember NodePort as it is an accessible IP address, but it is volatile. It can change from the range 30,000 to 30,767. So it is not efficient to access. So that issue is solved by load balancer that provides a static or a single public IP address that is not volatile. So now let's understand load balancer, that is external or cloud. Its function. Load balancer is specifically designed for cloud providers, that is AWS EKS, Google GKE, Azure AKS. It automatically provisions a native cloud load balancer, for example AWS ELB or NLB. Access reachable via public IP address or DNS name provided by cloud vendor. Mechanism, it automatically builds upon NodePort and ClusterIP to route external public traffic down into the specific pods. But before I explain load balancer, let's again understand NodePort accessibility. I mentioned NodePorts are volatile. Even if we try to access it, we can, but we have to specify those allowing the traffic for outside the cluster, meaning we have to specify in the AWS that we are allowing the traffic on these ports for public. And if we perform that and it generates a node IP and we try to access it, we can access node IP, but it is volatile. It can range from 30,000 to 32,767, so can change anytime. So it is not efficient. So it is solved by load balancer. So load balancer is a service provided by cloud providers. It provides a reachable public IP address or a DNS name that can be provided by Route 53 with respect to using public IP address by the load balancer. Load balancer has a mechanism that automatically builds upon NodePort and ClusterIP to route external public traffic down into specific pods and balance those traffic so no single pod gets overwhelmed by the traffic. So it balances all the load across the pods, and load balancer provides a single public reachable IP address, and if we try to access that IP address, we can access the application, and that IP address is not volatile as the NodePort, and it is a single IP address, and we can use that single IP address on the code ID or Route 53 after we create a DNS name, and we can provide that public IP address and we can access the application. Now service type ClusterIP, accessibility internal only. It is service, no cloud requirement. NodePort, it is external via node IP, direct access to worker nodes. It is not a cloud requirement, no. Load balancer, external via public IP, purpose production grade public traffic. Cloud requirement, yes, cloud provider. So that is it for the video today. Thanks so much for watching. Have a great day. Bye.